Yes. Yes. All right. I know. Yeah, really. I know everyone just transcribes my jokes, right? Come on, come on. Format. That's better. Alrighty. Let's see. Project-wise, there are discussion sections on Friday, and I'll release your next team project homework on Wednesday. Play Wednesday morning. Basically, what you're going to be doing next is prototyping, and that just means writing some code to test out an API, display some results. Nothing fancy. So literally, you don't even have to have a front end. And I suggested at least once to use Postman to do it. And on Friday, I'm thinking that Laura will also be talking about Postman just to show you how to set up an API call, how to get a query out of Postman, and so on. It's just a really fast prototyping tool that's easy to use. So that'll come out on Wednesday, and you'll have Wednesday, 1, 2. You'd like to give you like a week and a half to do that one. So you have a week and a half, 2 weeks to come up with prototypes. Yeah, it'd probably be 2 weeks so that you got this coming Friday with Laura. I guess technically you could demonstrate them on the following Friday. We'll see what the timing looks like. Anyway, prototyping coming up next. And today we're talking about OAuth for a couple of reasons. One is that a lot of times when you are using these APIs, like if you're using the Twitter API to pull down somebody's tweets, you're going to have to OAuth into it. Actually, your user is going to have to OAuth into it, and you got to write the OAuth code on the back end for your stuff. So I just want to talk roughly how OAuth works, what JWTs look like, because that's a technique we can use to authenticate somebody and keep them authenticated. That is today's stuff. And I apologize for the energy level. The time change just wrecks me every year. I'm just wrecked, and not in a good way. Like I'm fine being wrecked, but not with a time change, you know? All right. So here we go. Let me just make this a little bit smaller. Maybe I can even do this. What happens if I do this? It's not terrible. I can't move that though. Hang on. Exit. One of these days I'll remember just to like bring on an iPad and set up the chat on my iPad. Oh, shit, maybe I'll just do it this way. All right, we'll do it this way. Get you out of the way. Sweet. So here's the problem we've got. And I talked about this a little bit earlier. Welcome. The problem we have is that HTTP is a stateless protocol for the most part. I mean, there's been some work on that front, and Google's come out with a new protocol called Quick that allows us to do HTTP in sort of a stateful kind of way. But most folks are not running the Quick protocol. It might even only work in Chrome, the Google Chrome browser, which I don't use on my system just because Google is Brave instead. So I'd say still like 95% of the web is running stateless HTTP. The problem that we have is that every single request back to an HTTP server is a brand new request. There's no sense of what came before in the request itself. So, if I'm on Amazon, I'm clicking around, like every single click on Amazon to Amazon's side looks like it's the first time I've ever been there. What we want though is like this notion of a session. We want somebody to log in and then be logged in for the duration of the time that they're on the site. Even if they go away for a while, you come back 30 minutes later and you complete that purchase. Like we don't want people to have to log in every time you do a click. And that actually happened not that long ago. That was about 10 years ago. I guess there was an article in like Reader's Digest or something silly about the evils of of cookies. It's like, oh my God, people are stealing your computer's information with cookies, and you have to turn cookies off. And it was this whole dire article. And so like half the country, apparently Reader's Digest, just disabled JavaScript in their browsers, cookies rather. And like the web broke for at least a week, because cookies are one way to maintain session information. And the way a cookie works is that a cookie is just a little text file. Often it's encrypted, sometimes it's not. But it gets transmitted automatically on every request and response. So anytime you do a click, you do a request to a web server, if there's a cookie associated with that domain on your machine, it'll be sent automatically to the server side. And then likewise, it comes back, the cookie is sent back to your browser automatically on the response. You can see them if we go to, let's see somewhere where I'm logged in, like journal maybe. Let's go take a look at the cookies in here. Let's move that over here for a moment. And I'm going to do show source. I just did a right click, show source. What I'm interested in here is storage. So if I click on the storage control, this little storage button over here, BIP, now we'll see all the storage that's associated with this domain, wsj.com. And there's, as you can see, I didn't know they used Firebase for that. There's 3 main zones for storing data on the browser side. So one is the session storage. Session storage is temporary. So it only lives during like the session while you're sending stuff back and forth. And there's not much in here, as you can see. So there's a session ID, an identity ID that's probably mapped onto my subscriber information on the back end. Looks like interesting. They're having issues. Maybe they're logging stuff to debug. What's on the asset side? Nothing. So session storage, these are variables that are sent back and forth, actual variables sent on the request and the response. They really only exist on the connections. So when I click on something, those session variables are attached to that request and off they go. I guess they're sort of like a cookie in that sense, except they're kind of not stored permanently. Cookies are stored permanently on your machine. Here's local storage. This is handy. Bunch of stuff in here, right? So local storage is, again, sort of temporary, but it's actually stored on the file system on your machine. So things like who am I, what's my locale, at least my language, do I want to use the new fonts, all this stuff that I've chosen. Local storage is relatively permanent. So anytime that Wall Street Journal wants to write preferences information, for example, to my machine, they'll write it to local storage, and that persists. So even when I close the browser or close the tab, next time I open it up, the stuff in local storage is still going to be there. And you can see like there's interesting stuff that they might need on the back end for this. Typically, when I'm using local storage like this, I'm not really sending a lot of stuff to the back end. What I'm really doing here is I'm reading local storage from JavaScript on the front end, on the browser side. And maybe the first time I hit the site, it's going to load up a preferences object, for example, and send it up to me. And then we'll store that preferences object on the front end in local storage so that the next time I go to the site, I've got all that preference information already local, so I can save the network trip to pick it up. So that's the local storage. Still nothing in assets. And then finally, cookies. Here are the cookies for the site. Oh, they have wsj.net and wsj.com. So the cookie is tied to the domain wsj.com. These only work on wsj.com. Theoretically, Google allows third-party cookies, which we could probably trace the demise of the World Wide Web back to Google allowing third-party cookies on sites, mainly for advertising. But this is information that, again, is persistent. This lives on the file system. There's a directory in the file system that's called cookies that holds all of these things for each domain. And you can see them from If you go to the develop menu, somewhere in here, there's a way to see all of your cookies. You can go to Safari preferences, and there's a cookies report over there. It's going to be in websites. So I can see cookies in here, I think it is. Or it's maybe security. Privacy. Oh, manage website data. So this is where I can see cookies. So a couple of different places to see them as a user. Programmatically, we just make calls from, this is front end, so we're calling from JavaScript to read these cookies or write to a cookie. And again, those cookies, this information is sent every single time I do a request. And on the response, this information appears on the response as well. They have two cookies because they're associated with a domain, and WSJ.net is different than WSJ.com from a domain standpoint. And so I need two different cookies for that one. You'll notice there's an HTTP only flag over here. So secure means it's encrypted. HTTP only means that you cannot open that cookie on the browser side. You're restricted basically from seeing the contents of the cookie. And we're actually going to leverage that when we talk about logging somebody in and keeping them logged in. I'll show you how to set that. It's pretty simple. All right. Oh, and notice that they have different expiration times too. I'll show you how to set the expiration time as well. Excuse me. Anything happening? Retail sales down 3%. Cool. I became addicted to Wall Street Journal when I was working at Fidelity. Spencer asks, is local storage the other stuff that eats up 100 gig of my hard drive? Nah, it's all your music, dude. Yeah, probably not. Probably not. These are really, really tiny. These are just tiny text files. Yeah, a couple 100 bytes probably. Yeah, my problem is music. I just got way too much music. There's probably a way, but like I've got a big machine at home, big ass machine, that's got giant storage, and when I load stuff up into Apple Music, it just appears everywhere that I have Apple Music, which really kills my browser cache. Yeah, maybe. It really kills my file system. Browser cache, not even browser cache, because when you think about a cache, like Andrew asked about browser cache is taking up space. Caching, that's usually a really temporary thing. Like when I close a browser, I'm clearing all those caches out, mainly because I can't predict when I'm going to open the browser back up. And it doesn't make sense to persist a lot of stuff in a cache that is likely to be stale when I go back to read it again. Because I'm going to have to reread it anyway to make sure it's not stale. So there's no reason to persist that stuff. All right, so that's the problem that we've got, that HTTP is stateless, and by that we just mean every click is a brand new thing to HTTP. Let's stick it down here maybe. God, Zoom is just killing me. All right, so I mean, part of the thing is that like we want the server to be stateless. It has to be stateless, and by stateless I just mean that there's nothing on the back end, like in the processing of your request. It doesn't say, oh yeah, I remember you from the request itself. Like that would be horrible, because these are just functions on the back end. So if I hit the back end, it calls a function. And if that function is persisting state in some way for every single user that hits that function, that's just a mess. Like these are functions that we want to hit the function, it's going to do some work, and then get out and be reset basically for the next function call. Or I might even call them several times, like, hit those functions almost in parallel. Like it's just not a really clean way to store that data in a function. So we want the server stuff absolutely to be stateless. It would be horrible. Like you could write it, I guess, but it'd just be a mess. And so it's much easier to send something back to the back end, like a user ID or an encrypted user ID, and then look them up. And that's what's happening. We send session information. It's like, oh, Donham's logged in. Here's his user ID or some value that maps to a user ID. So when I send the request to the back end, it looks in there, looks at the cookie, gets my user ID out of it, and then does a database lookup And the database lookup tells the backend who I am, where I just was, what the number of my shopping cart is, that sort of stuff. So they're looking it up every single time. Now that stuff is probably cached on the back end because that stuff makes sense to cache, right? I don't want to hit the database every single time a user clicks Amazon.com. Like, no, I'm going to save some of that information in memory on the back end. I wish I could see these. It's a little bit better. All right, so these are just all reasons that we want to do this, basically. And it makes sense to look them up to get information about what they were doing and so on. So there's two kinds of authorization, or auth, basically. Unfortunately, they have the same stem. So authentication is different from authorization. Authentication is just ensuring that somebody is who they said they were. That's a login, basically. So I'm using a password there, thumbprint, retina scan, like whatever it is. I'm going to authenticate somebody. And then the authorization piece is more role-based. Oh, Donham is just a regular user on Amazon, just a some schmuck that buys socks, and so I don't have a lot of high-level like admin roles. That's authorization. There are parts of the site that I can't get to because I'm not authorized, but I'm authorized because I am authenticated. I can't really. I guess I could have a role for unauthenticated people. They probably just read-only stuff. But the steps usually are authenticate first, and then based on the authentication, now I can look up the roles and do authorization sorts of things. That's how that works. Boy, I just read a white paper or a report. Was it a CERN report? I can't recall who it came through. Brian Krebs, a security researcher. Basically, there's a company who will force forward SMS calls. So like I don't know, let's say that Spencer, I want to attack Spencer in some way. I can send a letter to this company, and if I know Spencer's phone number, all I have to do is attest that I am authorized to receive calls on that number, and some small amount of money, like $20 or something, you send that to this company, and they have, because it's a telecom company, they're able to forward those things. So I would see all the texts that came across Spencer's phone on SMS, at least, which means if you're using SMS for two-factor authentication, I'm logging into my Fidelity accounts. Oh, next up is to send a code to your phone. If they're using SMS to send that code, all of that is broken now. As of yesterday, you can't trust it anymore, which is really interesting. I don't know how much fallout there's going to be out of that one. So anyway, it's the two auths, authentication and authorization. And, I'll probably ask on a quiz or something at some point, like what's the difference between the two? So don't forget this slide, bookmark the slide. I just talk about auth, and I kind of mean both. So you'll have to get out of context if I'm talking about a login or some sort of role. Yeah, Andrew, I think it's just really, SMS, short message service, it's been around forever, like pre-smartphone even, and it's just really insecure. But a lot of companies fall back on SMS if you don't have something like, if you're not using a dedicated app for messaging, SMS is the fallback. I feel fine because I use iMessage through the Mac to get messages like that, two-factor authentication stuff. So, if you're doing that, you're probably safe. Yeah, it's just another example of the technical systems that we put up, like telecom and computing and so on. They're just really naive, and frankly, people suck at this. Clearly, we've been writing code for 50 years, and this kind of thing still happens. So you just can't trust anything, really. Whoa, that's a big old message from Yuval. So does OpenID Connect combine both of these? I was looking at auth the other day for Google. Seems like OpenID is the new way to combine both auth and authorization. Maybe. OpenID is kind of an open source kind of universal ID The problem I have with OpenID is it's been around a really long time and essentially nobody is adopting it or has. I know Google likes it, but even Google doesn't really use it, I don't think. So the short answer to that, Yuval, is I'm not sure, because I haven't really looked at OpenID all that much, just because it's like, why bother? It's possible. Although as a central authority for auth, like I would assume they're just doing authentication. Like if you're not connected to any sort of app or anything, you're just sort of proving identity. Like, how do I know what roles you have on those sites? I think I'd still have to look up roles on the back ends of each of those sites that was using OpenID. That's just a guess. All right, so here's a simple case. Here I'm using a cookie here. This the code in the examples will be JavaScript, because typically we're talking, or at least I'm talking Node on the back end, or Angular or something on the front end, React or something. So here's a simple one, like, I mean, don't do this at home. This is just a cookie, and it's the key value pair inside of a cookie. So the key is auth status, the value is true. This res.cookie, for those of you who know some JavaScript, backend JavaScript, res is the response object. So this function would be run in the context of a request coming to the backend server. So I've got a request object, a response object, and then next is the way we chain functions in JavaScript, or at least in Node. It's a callback function. So res is the response object. What this is saying is res.cookie says set a cookie on the response and give it the key value pair auth status true. And then the options here are, I'm going to set HTTP only to true. HTTP only just means I can't open it on the front end. I always wondered about that. Like if I'm in debug mode on the front end, can I see that cookie? Makes it harder to open, I'm guessing. So it just sets the cookie and then does a res redirect. Response redirect means I'm going to take the incoming request and redirect it somewhere else. In this case, I'm redirecting it to the top side of this site. / is just the first, the landing sort of page, the default route on the site. And so this person is now logged in, or at least they have an auth status of true. How I use that, who knows? So those cookies, again, they're sent automatically. The problem is this, like anybody can walk up to somebody's machine if they're not around, stick a thumb drive in it and copy the cookies folder. It's just a directory and it's in a known place on each machine. I can't recall where it is on any machines. I think on Windows, it used to be in like System 32, something, cookies. I'm sure it's in a directory called cookies on a Mac. If you go to the top of your file system and just do a find on cookies, you'll probably find one, or at least find the directory. So it's easy to steal the cookies. Like that's a trivial task. It's like the first line of attack if I'm trying to take somebody down. If I have physical access to their machine, I'm for sure going to copy their cookies off. So I need to be able to guarantee that a user is who they say they are, even though they've got the cookie. And that's where JWTs come in. So JWTs, a JWT is a JSON web token. We talked briefly about JSON when we looked at data. So JSON is just it's an object format that I can write, just text. I can write out an object with functions or with attributes, like key value pairs inside of that thing. So I'm going to use a token like this to basically guarantee that the user is at least the logged in user when they initially authorized with me. I'm going to generate a token, send that to them in a cookie that's sent automatically back and forth. And that gives me some sense at least that they probably are who they said they were. And by the way, even though the JSON is in the name of this and it's JavaScript, object notation, you use these everywhere. So Python, Perl, C, like whatever you're writing your code in, JSON web tokens are available to you. There's going to be a package for them. And you'll see they're so simple that, like, why else would you do it any other way? Like, this is probably the simplest way to manage this data. So the format, there are 3 pieces in the format. There's a header. The header is typically generated for us, so we don't have to really worry too much about the header. The header has things like what algorithm we're using to do, we're going to end up doing a hash on the thing, like which hash algorithm did we use, that sort of thing. What kind of token is this? And then the payload is what we're really interested in. The payload are the key value pairs that we're sending back to either the front end or the back end. I don't know, they use the word claims for some reason. It's just key value pairs. And then finally, there's a signature. It says it's generated cryptographically. That doesn't necessarily mean that the cookie itself is, the token itself is encrypted. It just means it was cryptographically signed. And we'll see what that looks like in a sec. So all of this stuff is base 64 encoded. The header and the payload are encoded. Then we generate a signature against it, basically take a hash of it, and then base 64 encode the hash also. It ends up looking like this. So the signature is not shown here. The header would be this red bit here. That's the base 64 encoding of the header. In purple is the base 64 encoding of the payload. And then the blue bit is the hash of that base 64 encoded. Now, if you don't know base 64 encoding, let's delete, let's draw for a sec real quick. It essentially looks like this. So here's the problem we're trying to solve. Please. Text. Here's the problem we're trying to solve in base 64. It's that the networks that we use, the connections on the networks, they're not guaranteed to be 8 bits safe. So if I've got 8 bits to send, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So if I got data that looks like this, just binary data, right? These are 8-bit bytes. The problem that we have is that there are a lot of telecommunication systems in the world that are still based on characters being sent across the network. And in most cases, that character encoding is 7-bit. It's ASCII stuff. So we just can't be guaranteed that 8 bits of information is going to go through those networks. And so we have to encode the 8-bit stuff into a smaller unit that we have some assurance will go through this kind of a network. And so we use base 64 encoding to do it. It's called base 64 encoding. I'm essentially going to take this stuff. So what's 2 to the 8th? 2 to the 8th is 256, right? So I've got 256 encodings in 8 bits. That's just saying that in 8 bits, I've got 256 different combinations of zeros and ones. I'm instead going to crank that down. 7 bits is like, yeah, I could maybe use 7 bits and that would go through, but what if I had parity bits and so on? So we crank this down to 6 bits. It's called base 64 because what is 2 to the 6th? It's 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 34, times 2 is 64. So 2 to the 6th is 64. So we're in base 64. And the way we handle this is we just break these things down into 6-bit chunks instead of 8-bit chunks. So it's going to look like this. I apologize if you guys know all this. I shall start on the other end. I don't have to pad anything. Doesn't matter where I start. So 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So now I've base 64 encoded this stuff. I've taken the 8-bit bytes and chunked them out into 6-bit pieces. And these were all on 8-bit boundaries, so I don't have to worry about extra bits over here. If I had extra bits, I'd just throw zeros in front of them to get to 6 bits. That's called padding, P-A-D-D-I-N-G. So that's this. And now I'm going to take this information and basically assign a character to each thing. So the characters look like this. 1, 2, 3, 4, 5, 6 is an A. 1, 2, 3, 4, 5, 6 is a B, and so on. So I've got lowercase letters and uppercase letters, digits, and I believe 2 pieces of punctuation, and that's it. It's probably a table out here we can find. Bless this. A table we can find. Base 64 encoding. Why does it say decode? Actually, an image we can find. What's that? Yeah, thank you. So I'm just going over the table. Here's the table. So that's a base 64 table. Oh, I got it backwards. So 0 is a capital A. And then a little a is 26. But you can see I've got A through Z. A through Z gives me 51 characters, and then 0 through 9, and then plus and slash are my 2 punctuation characters. So basically you'd end up with this. You would encode each of these into a character and then send those characters over the network. If you've ever seen images that have been sent in email, no one does this anymore. If you look at the source of the email that has an image in it, you'll see that it's a MIME type, a multimedia mail extension. The MIME type encodes the images, which are 8-bit images. It encodes them into base 64. So you'll see just a whole bunch of A's and B's and numbers in your email source, something with an image in it. Anyway, that's base 64 encoding. It's not encrypted. It's just encoded on the, anyone who gets a base 64 file or a network connection, they can just unbase 64 it and go right back to what they were looking at. We use, is it B to A and A to B? So there are a couple of functions that are pretty common to use. A to B and B to A. Those two will take a binary and spit out base 64. A to B takes base 64 and spits out the binary version. All right. So we're going to sign this thing. We're going to sign it with a hash. And the hash, I'm sure you've run into hashes at some point now in your time here at BU or outside BU. Hashes are essentially a mathematical function. It's a one-way function. It takes some input and creates some unique output. The idea is to map one-to-one some input with an output, but do it in a non-reversible way so that if I have the hash value, I can't reproduce the original. Instead, I can use it to make sure that the original didn't change. So like this, if I have, let's pop open this real quick. Where am I? CD, that's fine. Do I have a lorem or something here? Yeah, so that we looked at this lorem.txt earlier. So it's just lorem ipsum. And if I take a hash on that, like an MD5 hash, it's going to give me some value, 7F blah, 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 ED7. If I change anything in that file, so let me just, I'll go down to the bottom and just add a space. Like you wouldn't even notice that, right? But now if I take the hash again, you can see it's a completely different number. So we can use the hash as an indication that nothing has changed. And you'll find, like, if you're downloading software, for example, like serious packages, they usually include the hash of an executable or the hash of a tarball so that you can have some assurance that the executable file hasn't been modified between the time you tried to download it and the time it got to you. Like no one has intercepted that and tried to modify it. The hashes would not be the same. Unfortunately, most sites that do that, like it's a really nice idea, but almost every single site that I've seen that uses hashes on executable files that you're going to download, they provide the hash right next to the executable. So you download the executable, and then the same page, you can download the hash for it. Like if I'm attacking something like that, the first thing I'm going to do is attack the domain so that I own that domain for some period of time, and I can put whatever hash value I want up there, you know? I actually had I wonder if I still have it. One of my shower ideas was, there should be some central place where I can record the hashes of common binaries so that you don't have to rely on the producer of that binary to guarantee the hash. It's called like, it's hashchecks.com. I'm sure I still own that domain. I just never have filled it in. Like actually done the work. I had the idea. Anyway, so that's a hash. And that's how we're going to guarantee that the stuff inside the token hasn't changed. Put it on the blockchain. Yeah. Yeah, why not? Well, even the blockchain bit, like that only guarantees that it hasn't changed. It doesn't prove who inserted it to the, well, I guess I could see the input on the blockchain, right? Where it came from. Authorization is hard. All right, so we can stick this JWT. So the JWT is going to end up looking like this. So in this case, I've got the payload is just my name, whether I'm an administrator, what my user ID is. That's going to end up showing up on both sides of the connection, request and response, if I stick it in a cookie. There's a couple of ways to do it. Like I could stick this in a header when I'm responding to a request, for example, or even initiating a request. You can set headers. I can't think of a really fast way to show you some headers, but I can set all sorts of HTTP headers. HTTP headers. See if I can find them this way really quickly. Oh, MDN, of course, has them. So headers look like this, like keep alive, trailers, here's some authentication stuff. There's an authorization header I could use. And I can say what kind of authorization. Is it bearer or whatever? Pass credentials on it. So here's a basic authorization header on an HTTP request, this be a request. And that's fine. Like this thing is going to be a token of some sort that I'm passing back and forth. Maybe it's even the hash of a JWT. So I could hold the JWT on the back end, the authorization stuff on the back end, hash it, and just pass the hash back and forth, store the hash on the front end. When it appears on the back end in a request, look up that hash in a database somewhere and see who that person is. The trouble, I mean, these are fine. Like you see HTTP headers being used for authorization all the time. In fact, you'll probably see some when you do your API calls. A lot of sites just use authorization headers for that purpose. The issue is that you have to assemble that header on every single request and response. It's not automatic. On the back end, if I want to include the authorization headers, I've got to build that header and insert it into the response. Same on the front end. If I want to send a token back on an authorization header, I've got to build the header, put it on the request, send it out every single time. I mean, there's nothing wrong with that. Clearly a lot of folks use it. It's just that it's not automatic, and I like automatic stuff just to make my life easier. I could stick it in local storage. In fact, I probably will stick it in local storage. Like if I wanted, you know how like you sometimes see the remember me sort of button so that the next time you go back the next day to a site and you're still logged in, they're just storing something like this in local storage and then sending it on a cookie on that first request. And that says, oh, here they are again. Who is it? Oh, open up the cookie. Oh, that's who they are. And then load up their preferences and account stuff from a database. So we can do it that way. That's, in fact, we'll probably combine a JWT with some local storage. The issue with local storage is that now I'm exposing it like maybe somebody sells the laptop and it still has that token sitting in a cookie somewhere. So that, great, I'll go to fidelity.com and it matches the domain. So now I send that cookie and now I've got what looks like an authorized token. So that can be a risk. All right, so we're going to put them in a cookie. I can actually sign these things, by the way. Like you can actually sign the you can sign the token with like an RSA kind of signature, like a public-private key kind of thing, which raises other issues. One thing I didn't mention about this was, here it is. I probably should have Should have raised this when I saw this slide. So that's signature. We're talking about the hash. The signature is generated from the header and the payload plus a secret on the back end, plus a secret. So for example, they could just be a little string, but it's only on the server. Only on the server. Why? Because that way, if I hash with a secret that only the server knows, and by with, I just literally mean concatenating the header, the payload, and a little secret, and then taking the hash. If I do that on the server side, the client side doesn't know what that secret is, and so they can't generate a new token that matches the hash in some way. They just can't. They can't really re-sign that token in a way that wouldn't be detected on the back end. So the secret is a big deal, I guess. So the problem is that if you want to validate that JWT on the front end, you have to know the secret, which is like the last thing we want. We're not going to do that at all. And so we're just going to keep that secret on the back end, which means that we're really just going to pass this token back and forth. The client side probably won't even know that they have the token. I mean, we will as coders because we put it there, but like there's nothing visible. They'll just be sending that back automatically each time. Here's that's the algorithm, or the function call rather, for the signature. So you can see it's the header, base64 encoded, payload, base64 encoded, plus the secret, and was taking a SHA-256 on that. As I mentioned, you can use RSA, like a public-private key pair, to sign these things. Now I've got the same problem. If I want to validate that signature on the front end, I need to have some way to provide the public key to the front end. So I'd have to have some sort of endpoint on the back end to retrieve that key. What is the public key? I mean, public keys are public, anybody can see them, but it's still an extra step. I need to be able to retrieve the public key to decrypt the entire thing, which was encrypted with the private key. And I'm not going to talk about RSA and how to do that because we're not going to do it. And that's more of a security thing, I think. All right, so we're not encrypting, we're just signing, Let's talk about using these things. It's actually really quick on the back end to validate this, because really all I'm doing is regenerating the hash and making sure the hashes match. And if it's a cookie, it just appears on every single request. So I don't have to worry about finding it anywhere. It's just going to be sitting in the cookie set coming from the request. But what about third-party stuff? So like if it's just us, right? This is trivial. All I have to do is authenticate somebody on the back end with a password or something, generate this token, hash it, and then send it to the front end on the cookie. The next time they send that back to me on the next request, it looks, I can validate that the cookie is correct, or the JWT is correct inside the cookie. So it's really simple if it's all our code. When I get a third party involved though, and this is mainly where we're going to use this, now it gets a little more complex, because now I'm basically outsourcing authentication to somebody else, which honest to God, I think is a horrific idea. Like, I don't understand how this became popular, but it is. Like, everybody's using this. And I'll show you how to do it. In fact, I'm asking you to do it on your project so you can see how it works. It just doesn't feel good to me to ask somebody I don't know to provide authentication for my application. Like, I don't know those people. I don't know the coders. I don't know what's in their code. Who knows what they're doing, right? So it's a matter of trust, I think. It's sort of like the cloud, storing files in a cloud. I don't. I built my own private cloud to store all my files in a private cloud because I don't trust anybody else. Like, why would I send all my files to somebody I don't know? It's just, I don't get that either. I use C-File, by the way, SEAFILE is my cloud. All right, so I'm going to do third-party authentication, and that'll be the only rant I do about that, because we have to figure out how it works, right? So this is essentially calling somebody else, like Twitter. Like, if somebody wants to log into my application but I don't want to have to deal with authentication. Like, that's a lot of work to properly authenticate somebody. The assumption is that these big companies like Twitter and Google and so on, Spotify, like they've done that work. They have a decent authentication system in place. So we're going to leverage that. Basically what's happening is your user is logging into the third party, Twitter, Spotify, Google, whoever it is. And then that third party is generating a token that says, hey, this user logged in successfully on our side. That means that I suppose we have some level of trust that they're an authorized user. It goes with authorization as well. So if your application is reading a Twitter timeline, like you as an app don't have authorization to read somebody else's Twitter timeline. And so what we do is we log them into Twitter using OAuth. And then part of that OAuth request is log them in, and I want permission to read their timeline. So a token is generated to give us that access and returned. The next time that we want to see that user's timeline on Twitter, we present that token to Twitter. So that token, remember, was generated on Twitter's side. They have some sense that, oh yeah, this user logged in with us and said that this specific app could read their timeline. And so they grant that authorization. It's been around a long time. And I actually remember where this came from. There was a move right around the turn of the century for sharing bookmarks. There were some extensions to some of the earlier browsers so that if I had a cool bookmark that I wanted to share with my wife or something, I could, like, there was a shared space for those things, and she could see bookmarks that I had authorized her to see from mine. So there was this sharing of browser bookmarks going on, and Twitter wanted to leverage that stuff and allow people to like see their side also. It was kind of around OpenID and that concept of a universal ID for folks to log in across the web that kind of never went anywhere. But Twitter did a lot of the early work, and it actually worked great for what they needed it to do. And then it started becoming popular just for general authentication. And that's kind of where we are today. We rely pretty heavily, frankly, on third-party authentication. And again, I'm not sure that's a fabulous idea. There's a couple of versions that are incompatible with each other, of course. It's like Andy Tannenbaum. The nice thing about standards is that there's so many to choose from. Well, here we go. We got two completely incompatible standards for OAuth. It just means that from your standpoint on the app side, when you're working on projects, for example, you just need to look up in the documentation which version is my third-party OAuth client using. Are they using one? Are they using two? Some of them use both. So I have endpoints for both 1 and 2. One is the original one, of course, and that's what we're going to look at today in terms of handshaking and how the connections are made. OAuth 2 was invented because they thought OAuth 1 was too complicated. And they make some assumptions in OAuth 2 about encrypted transmission channels, basically HTTPS. They assume that the connection is coming in on HTTPS, and so they drop a lot of the encryption requirements that OAuth 1 had. I'm a little queasy about that too. When you start making assumptions, like I get really nervous around assumptions. There were some performance issues with even 1.0A rather. So I don't know. When I'm doing OAuth, I still do OAuth 1 for my own apps. So the two flavors, kind of just what I said. Let's talk about the handshaking. There's a multi-step process that goes on. And like the problem that we've got is, again, it's a trust problem. Like, who do we trust and when do we trust them? Because think about what's happening. I basically have 3 individuals or 3 entities. I've got the user. The user's unauthenticated at this point. Like if they make a request on my server at the application side, if they make an application request, I have no idea who this person is. They're unauthenticated. I don't know who they are. And so what I'm saying is, oh, hey, Twitter, like go handle authentication for me. Like Twitter doesn't know me from Adam, my application. Like how's Twitter going to trust my application, right? And then I'm sending a user to them. It's like they don't know the user either. Like they have the same problem I did. They don't know who the user is. Like they've got to authenticate them there also. So there's this really weird trust issue that goes on. Who do we trust? And how can we establish trust among three parties in such a way that all three trust each other, but none of the three really know about each other? It's a really interesting problem in security. So essentially, it looks like this. Yeah, this is kind of a complicated flow, but I'll just tell you kind of what happens. Yeah, so it's the application, the third-party OAuth users in the middle here, and then the actual application user on the right. So essentially what's happening is that the user comes to the app and says, hey, I want to log in. I can't really trust the user yet. And so on the back end, the application side, I'm going to ask Twitter to give me a token that I can give to the user. It's almost like, you know, the movies where the guy comes up to the bar door, the speakeasy, and knocks, and, you know, the hole opens up and he says, Fred sent me. And then the door opens. That's what I'm doing. I'm trying to give the user a message to give to Twitter that Twitter trusts. Well, to do that, my application hits Twitter and says, hey, I need a request token. A request token is essentially tied to the application at this point. When I make the request, I send Twitter a secret that was established when I built the application. You can see it over here. So this is this Twitter? Yeah, this is Twitter's side. So when I created the application on the Twitter side and said, hey, I want to use authentication for my app, they gave me a couple of things. They gave me an API key, this thing. They gave me a secret, which isn't shown here for some reason. It should be. There's an application key and an application secret. Basically, what I'm going to do is generate a request, and I'm going to sign that request with the key and the secret that were generated by Twitter when I set the application up. So there's some level of trust between the application and Twitter because the application's been set up on their side. And then I've signed that request. So Twitter says, oh yeah, this request, who was that from? What was the application ID? They look up the application ID and see, oh, okay, let's go make sure that it, you know, the key validates and so on. So Twitter trusts the application. Then Twitter generates a token, a request token, and hands it back to the application. So Twitter signs it on their side and hands it back. Now I've got a token that Twitter trusts based on the request from the application originally. So I've established trust between the application and Twitter, and now I've got a token that Twitter trusts explicitly because they signed it. You hand that token to the user. Say, hey, user, here's this thing that Twitter just signed. Go take it to Twitter and log in over there. And normally the user's not going to see that. We're just going to do a redirect, and they won't even see that process that's happened, you know, prior to them going to Twitter to log in. But when they hit Twitter, in addition to logging in, they're presenting this request token that Twitter signed originally. They're going to hand it to Twitter and say, hey, here's this great token. Twitter validates it and says, oh, you're great. They log in. But now I still don't trust the user. So the user's logged in, they presented the token that Twitter signed. Twitter now tells the application, hey, I think this dude's probably okay. They send a completely signed authorization token back to the application. And at that point, I can log the user in because I trust them at this point. In practicality, what I'm going to do is I'm going to take that information and stick it in a database. I'm going to generate some key on that record in the database. I usually use the hash of the token. And then I'm going to put the hash of the token in a cookie and then redirect the user again because I still have that connection to the user. I'm going to redirect that user they're going to now go to a page on my application, and they'll have the hash of the token in their cookie that they're sending back and forth in that JWT. And at that point, everyone trusts everybody, or at least the application, excuse me, and the user trust each other. And I can just use that JWT in a cookie that goes back and forth to guarantee that this is who they said they were. If at some point I need to, say, gain access to that user's timeline on Twitter, that's actually a different grant. So the first was just an authentication rather. Now I need to authorize them. It's the same sort of thing. I have to make sure that I can take my request token and get an access token from it, send the information up to Twitter and say, hey, can I exchange this for an access token? And they'll take a look at it. It's like, oh, yeah, that was all authenticated, perfect. They'll grant a new token that now I can use to send up to Twitter on behalf of the user. It's like a proxy almost. So there's all these little tokens being passed back and forth behind the scenes. It's not all that difficult. Let me see if I can. What time is it? Let me show you some code. Holy crow! Web storm. Oops. Sasrita has a question. The request may be the application of the user side. It depends. Well, all of the requests are coming from the server side. So the user never actually hits Twitter directly after the first time. So they're going to hit Twitter at one spot because they need to log in. And then from then on, it's the application making requests on their behalf using the access token that Twitter's given to us. And if you think about it, we can't have the user go to Twitter ever. Like all that access has to run through the application. And the reason is that if the front end is going to hit Twitter directly, they need things like a key and a secret. And if that stuff is on the front end, in the front end code, that's just exposed to the world because everybody can see the code on the front end. You can just open it up and read it. It's a JavaScript, it's interpreted, so you have to have the source code. All right, let's take a, geez, oh, Pete. You really do need like 9 screens to run these sessions, huh? Let's see where I'm at. Angular services, that's a service. Let's see if I can find, let's try that one. This window. If you're taking 412 with me in the summer, that's what you're gonna see, or in the fall even. That's where we get to. All right, let's see if I can find this. My head's been in C all semester. Auth check, auth Twitter maybe? Auth check. Check authorization. Where the devil is it? Oh, here it is. OAuth. So here's some auth code. This is backend JavaScript auth code. And I'm not going to go into the JavaScript stuff and the node things, but we can at least, walk through the flow really quickly just by looking at the function names here. So I've got users. So I've got a user with crypto. They look like this. Models. So here's a user. And you can see that actually this is a schema. So this is a Mongo database record. And I set it up with ODT, or is it ODT? Mapping, ODM. Mongoose is the ODM in this case. And really all the ODM does, Mongoose really is just enforcing the shape of this thing. So Mongo, as we saw when we were talking about data, Mongo just take anything and they'll store whatever you throw at it. Here I'm saying, no, these records have a specific format and here's what's in each record. And Mongoose sitting on top of Mongo will enforce that, that shape. So blah, 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 blah. Here we go, Twitter ID, Twitter access token, Twitter secret, and a token hash. That's the Twitter stuff in this user record. We're gonna use the token hash as the thing we send back and forth in the JWT. And they've also got, actually there's an example of we're talking when we spoke about Mongo, how non-relational databases, most of them are storing stuff in JSON format. JSON being object format, I can add functions to that. So here's a record. Like this is just, that's a straight up JSON sort of thing, but I've also added set password and check password to that record. So anytime I insert or take out that object from the database, it's already got these functions associated with them, and I can just run the functions, check or set passwords. All right, so that's my user. Yeah, let's go back to this really quickly. I'm going to use a couple of packages, as a crypto package, as a JSON web token package to make life a little bit easier. And I've got some Twitter code also. This JWT config, that's going to hold my secrets. So here's the config directory. Here's JWT config. Oh, in fact, it's just the secret that I'm going to use for hashing. And then here are the endpoints on the Twitter side. Yeah, and as I recall, I've obfuscated that one, so it's not my real consumer secret. But these are the things that are set up on the Twitter side when I set up the application for authentication. Here's my key, there's the secret, parts of the secret. Owner ID maps this application back to what appears on Twitter. And then these are the endpoints I'll call: authorized, request token, access token, and so on. So what's happening here is blip, 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 blip. I'm going to create a new OAuth object, and it's going to be a Twitter OAuth object. So these are all my Twitter configurations. What are my keys? What are my endpoints and so on? They're going to be sitting in OA. And then here's where I log in. So somebody wants to log into this thing, they're going to hit this. And it's probably a login with Twitter button that I've put up on the screen. Again, all these backends, really, they're just matching functions to actions on the front end. So a request comes in, you look at the request, you map it one-to-one with a function. This is the function that runs on the /Twitter path. And it does just what that chart said. I'm going to go get a request token. And I need stuff with the request token. It's all of this stuff. So when I created this authorization object, I passed in all of these bits. And this is doing some work for me. So it's formatting the request, it's signing it with the secret, it's making sure it's in the correct format for Twitter when I do this. And then when I get back from it, this function is a callback function. So I'm going to ask for the request token, and then this function runs when that request comes back. So that's a callback. And you can see what I'm getting out of it. I'm getting an OAuth token and a secret coming back from Twitter. Let's make sure that it's correct. If it is correct, so this is the one that Twitter has authorized my app essentially to let somebody log in with them. And you can see what I'm doing. I'm going to put on this session just that little token. I'm going to stick it right on the session. I don't even have to put this in a cookie or anything. It's just going to be sent to the user. So it's got the OAuth token in it and the secret. And then this redirect, notice where I'm redirecting them to. So this is somebody came to me, said, hey, I want to log in. I said, hey, Twitter, can they log in? Twitter gives me a request token. Now I'm handing that request token back to the user to take to Twitter. And this is how they take it to Twitter. I'm doing a redirect on the session, redirecting them to twitter.com/OAuth. And they're getting that. They're getting the token that we just built that Twitter handed to us. They're getting that as part of that request. So they're going to end up at Twitter. The token's handed to Twitter on the user's behalf. They log in, and now Twitter calls the server back, my application. Now the user's logged in. They say, hey, they've logged in. And I get that request token back, and I can validate it. Just make sure there's a verification on that token that Twitter hands back, says, yeah, this user really did log in. Great, now I can log them in. But I actually need one more thing, because I'm going to display their Twitter stuff. I need permission to see their timeline. That's the access token. So at this point, they're logged in with Twitter. Twitter's redirected it back to my side. So they made a callback here. Here's the route they're calling back, cold callback. Now I'm going to ask for an access token. So same idea. It's like, you know what, go get me an access token. Here's the token that you just handed me. That OAuth token is the one that Twitter signed after the user logged in. So I get that back. I'm going to send it back to Twitter and say, now I need an access token for this user. That's where you see the, you know, this application would like to read your timeline, write to your tweets, eat your lunch, you know, okay, click OK, and off you go. So they give me permission, and what I get back now is an access token. And an access token secret coming from Twitter. And again, the user's not getting involved a lot here, right? Now I've got a logged in user because I got the signed request token back from Twitter, and it had been verified saying, yeah, they're logged in. I just requested an access token. The access token gives me access to the Twitter, the user's timeline. That's what I'm going to save. It's the access token I'm really interested in, because that's going to be sent back and forth to Twitter every time the user wants to see something on Twitter. Excuse me. So here we go. I'm gonna go and hash the thing. Where's my Twitter ID? Blah 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 blah. And I'm gonna take that access token. That's the one that came back from Twitter, and hash it. Now I've got a Twitter access token hash, and it's that token hash that I'm going to use as my key right there. So when I'm looking up this user on the next request, I'm going to use the hash of their token to look them up, which means that's what they're going to be sending back and forth in their cookie. But that user record, so this is a Mongo request to add this to the database, just get their ID, their screen name, their username on Twitter, and then their tokens plus the hash. Now let's put it in a JWT. So my JWT payload is going to be the hash in this case, and then we'll sign it. I've got a header. The payload is just the token hash. Now I'm going to sign it, and that means taking that hash and then base 64ing it. So now I've got an auth JWT token that is the hash of the access token. I'm sure everyone's following this. Like, you know, oh yeah, of course, that's what's happening. Now we put it on the cookie. Stick it on the cookie. The cookie options are it's HTTP only, so it cannot be opened on the client side, browser side, and expires at 0 makes it a session cookie. When you close the tab or close the browser, that cookie is destroyed. It's not persisted in local storage. And then here we stick the cookie on the response. That response is going back to the browser. What's on the cookie? It's called Twitter Access JWT, and it's got the auth token in it. And now we just do a redirect back to the top page of the site, but now they've got that cookie. And from this point on, that cookie gets sent back and forth. So anytime they want to do something like, here's a show account, they want to see their account information from my application. Well, I'm just going to go and call the Twitter API, a show account piece of the Twitter API, and look what I'm doing. So this part authenticates the application, and this part authenticates the user. What else can I do? Show favorites, same idea. I'm going to authenticate the app, authenticate the user, and then do a get. That get is going to be on Twitter's side. So this is give me my favorites on Twitter. And I'm passing this information back to Twitter so they know that this person's been authorized to see it. Now you'll notice this check authorization up here. What do we got, 2-3 minutes? Here's what check authorization looks like. Auth check, is this one? Yeah. So this is when somebody comes and says, hey, I want to do show favorites. I want to show my favorites on Twitter. The next thing that happens is this check authorization step. That's a function call. And it looks like this. Oh, for God's sakes, get out of my way. Here's check authorization. It's a function. It gets the request object, the response object. So that's the request coming in, the response going back. Well, look what I'm doing just to make sure that they're authorized to see this. So I look at the cookie. If there's no cookie on the request, that means they didn't send me a cookie. That means they're not authorized. They're not authenticated even. And so I just 401 them. An HTTP 401 response is unauthorized access. So that goes right back to the user and they see an unauthorized access message on their screen. If they do have the cookie, now I'm going to make sure that it's got what I expect in it. So I go look at the payload of the cookie, and just this JWT verifies a function call. I pass it the secret that I used to sign that token earlier. That's the secret. And it just verifies whether the token has been changed or not. If it passes verification, I get the payload here in user payload. So let's assume it passed verification, like, oh yeah, that's the cookie that was originally signed that we sent to them. They sent it back. That's cool. You know, they've got a cookie. It's got the right thing in it. Now let's go look them up. So what's in the cookie is the hash of the user record. Go find them in the database using that access token hash. If they're not there, they're not logged in, because when I log somebody in, I write them to the database. So if they're not in the database, maybe they stole this cookie from somewhere. So if there's no user, immediately clear the cookie on the request and then 401 them. So I destroy the cookie so they can't use it again, and then send them an unauthorized access. Otherwise, they're good to go, and they are authorized, and off they go. All right, I got one more slide on. Yes, a few tips. You can read these tips on your own. The big thing is that this one, on those access tokens, you're going to run into auth providers that limit the time on their access token. So that Twitter access token, let me see your timeline, they might put like a 5-second timeout on it. It just means that I need to get an access token every single time I want to access the service on the user's behalf. Twitter doesn't, so we can have a nice little session with them. All right, guys, I'm a minute over. Sorry about that. Hey, there's no class on Thursday. Do not do any work on Thursday. It's a day off. Well, I'm not working for sure. So I'll talk to you. I'll talk to you tomorrow when I post the assignment for the teams. I'll see you all on Piazza. Bye. Peace out. Gotta run.
Thank you, Professor. Have a good one.
Oh, it was a lot of fun, guys.